The longtime fans of this channel might remember the video where I showed you how I've built my 2-node Proxmox cluster that I'm running in my home lab. And honestly, that project was pretty cool. We used a small QDevice to get quorum, the cluster worked, and for basically learning how Proxmox clustering fits together, this setup made a lot of sense. But there was one big problem. The moment where I wanted to do some real high availability stuff, like doing live migrations, maintenance, and failover, that's exactly where this 2-node setup started to show its limits. So I finally fixed it. I just removed that old QDevice and added in a real third Proxmox server, put a new 2TB NVMe into each of the servers and built a proper 3-node cluster with Ceph storage. And now I can do this on Proxmox. I can take any virtual machine on my Proxmox cluster and I can do a live migration from one node to another. It's only copying the memory state of that machine, which takes less than a minute, while the ping keeps going and all of the services and applications stay online. And the reason why this works so smoothly is that the virtual machine disk is no longer sitting on one single server or on an external storage. It is distributed across the entire cluster using Ceph. And this is exactly the point where it becomes truly high available. So in this video, I show you exactly how I've upgraded my old 2-node setup into this new 3-node Proxmox and Ceph cluster, what hardware and network decisions actually matter, and we will clarify if that might be your next home lab project. But before we jump right into it, let's quickly ask the question: if Ceph gives you shared storage across the entire Proxmox cluster, does that replace every other storage need? And honestly, no. I would still recommend having a separate NAS solution for your personal data, maybe your photos, videos, your project files, and especially backups. Because Ceph is great for high available VM storage, but it is expensive, needs multiple nodes, and it is not a real backup solution. And that is why I would always use a NAS in my home lab, such as the DXP 4800 Pro from Ugreen, the sponsor of today's video. The DXP 4800 Pro is powered by an Intel i3 CPU that comes with 6 cores, 8 threads, and boosts up to 4.5 GHz. It supports DDR5 memory with up to 96 GB, which is insane, and you get 4 SATA drive bays that you can run in RAID 1, 5, or 10, plus you get 2 M2 NVMe SSD slots that you could use for fast caching, with up to 144 TB in total. And for networking, you get both 10 GB and 2.5 GB Ethernet. So this device has enough power and storage for all of your backups, media, and running workloads. I also personally like a lot the practical hardware design, because the hard drive bays are easy to slide in with a clever system to mount the drives completely without screws, and the magnetic filter at the back is super practical. It's a great NAS for any home lab. And on the software side, the UGOS Pro gives you simple setup, multi-user access from the web, mobile, desktop, and TV apps, and an app center with third-party apps, Docker and VM support, and the security manager. So if you want a dedicated NAS for data, backups, and more, the Ugreen NAS series is really incredible and now available on the Ugreen's website and on Amazon. Of course, I will drop you links to this in the description box down below. Alright guys, so now let's take a look at exactly how I've upgraded my old Proxmox cluster. And first of all, if you're completely new to this setup, I would still recommend watching my first video about the 2-node setup, because that video is really the foundational part. So there I've explained how to create a cluster on Proxmox, how to join another node, what quorum actually means, and why I used a QDevice in the first place. But just to quickly recap to get everybody on the same page, in a 2-node Proxmox cluster, the QDevice basically works like an extra vote. So if one node goes down, the remaining node can still reach the QDevice and has a majority, and the cluster can still keep making decisions. Without that third vote, you could end up in a so-called split brain situation where both nodes think they should be in charge. No, this again was working great, but the biggest problem with this setup was again that it did not make the virtual machines available on every node. So even if the cluster itself was high available, the VMs were not, because you cannot just magically start a VM on another node if its disk is only existing on the failed server. So the only way to get this working is to use an external storage device that contains the VM disks, like my NFS storage server. But that also had its own challenges, mainly because then the cluster is heavily dependent on another external component, which itself was not high available. And because running VM disks on an NFS share over the network isn't an ideal solution at all, because you might run into trouble with latency or network performance issues, I just decided to get rid of this old setup and install a real third Proxmox node. Now, I know some of you commented under my last 2-node Proxmox video that I could technically also solve this with ZFS replication. And to be fair, yes, ZFS replication would have been a solution, but one thing that I didn't like was that ZFS replication still means taking a snapshot and copying the data from one place to another. So it's not really the same like having a shared storage that all nodes can access at any time. And depending on how you configure it, you can always have replication windows, because the copy job needs to be scheduled like every 5, 10 or more seconds, and you always have then to guess, well, what was the last successful replication, which could technically become a problem when running databases or running VMs with time-critical apps. And that is why I have decided that I wanted to use Ceph, because Ceph solves that problem a little different. With Ceph, the virtual machine disks are not sitting on one node or on an external storage server anymore. The storage is on the actual nodes itself, and it's being distributed across the entire cluster. So in my small 3-node setup with a pool size of 3, that basically means that one copy of each VM disk should end up on each node. So if one node goes down, the other nodes don't have to wait for some separate replication job to catch up. They can immediately access the disk and start up the machine. You might only lose the memory of that VM once a node stops working immediately, but if all the nodes are up and running and you just want to do a live migration from one node to another, this is a super smooth process because the disk is already available on every other node. You just need to copy the memory state of that VM, move it across the cluster without downtime. And Ceph also has a few other capabilities and features we will probably cover in some future videos, but for this one, I mainly just wanted to get Ceph working on Proxmox. There's just one thing you should check first, and that is what Ceph repository and Ceph version you should install, because Proxmox has its own Ceph repositories, and you should use those that match your Proxmox version and your subscription model. So on Proxmox version 9, for example, that is the Ceph Squid repository. And this is also where I immediately ran into my first small problem, because on my system, Proxmox showed me a warning because I still had an old Ceph repository configured for Bookworm. So before I even clicked on the Ceph install button, I just wanted to clean this up, and I disabled the old Bookworm Ceph repository, added in the new current one called Squid, no subscription, and after that I just refreshed all the package lists and installed all the available updates on all 3 nodes just to make sure everything else is up to date. Then I just selected Ceph on my first Proxmox node and started the installation. So here you should select the Ceph version again that fits your Proxmox version and pick your subscription model. Once the installation is complete, you can start the configurations. So here you need to select your public and cluster network interface for Ceph and set the minimum and maximum number of replicas in your cluster. And these are critical settings where you should not just click through without thinking, because these you cannot easily change later on. First of all, you have to select your public network interface. So this is the interface that your Proxmox nodes and any other clients use to access Ceph. So this mainly handles all the communication when you run a VM from a Ceph disk or when you move a disk. So this is is like the front-side storage network. And the second, the cluster network, is what Ceph uses internally for its operational tasks, such as replication, recovery, and rebalancing. So this is more like the backside network, because when you write data through Ceph does not just store this on one disk, it has to replicate that data to all the other nodes. And if one node dies or a disk fails, Ceph also has to recover and rebalance the data across the remaining nodes. So this is why you can select a separate interface just for that Ceph backend network. We'll talk about some tips and requirements in a minute, but just that you know, you can technically do it both on the same public network interface. So in my setup, I've done exactly that because I didn't have another fast network interface on all three nodes available for that. But yeah, more about that later. Then I just repeated this setup on the two other nodes. I installed the Ceph packages, selected the repository and ran the installation. And on the second and third node, the wizard should tell you that the configuration is already initialized. So you just have to do that once. And when that is done, you might see a health warning saying that the OSD count is 0 below the default size of 3. Don't panic, because this warning is completely expected right now, because you just have installed Ceph, but we haven't created any OSDs yet. But before we do that, let us slow down for a moment here and recap a little what we've just done and talk about the requirements, because this is where you can make many mistakes and bad decisions might get you in trouble later on. So a good planning and researching is key for this project. The first one you have to think about is the number of nodes, because honestly, Ceph really just starts making sense with 3 nodes minimum. And yes, I know technically you might also find some weird lab setup with just 1 or 2 nodes, special rules and compromises, but for this video and for the smallest setup I actually would recommend in a home lab, you just need 3 Proxmox nodes. And I want to be clear, 3 nodes is just the minimum baseline for Ceph. It is not even the perfect production recommendation. Proxmox own Ceph documentation says a hyperconverged Proxmox plus Ceph cluster needs at least 3, preferably identical servers, and at least 12 OSDs evenly distributed across the nodes. By the way, OSD stands for Object Storage Daemon, and that is basically the Ceph process that sits in front of a disk. So this writes the data to the disk, reads it back, reports its health to the cluster, and helps with recovery if something fails. And that is the second requirement. Proxmox recommends 1 OSD per physical disk, which means in a 3-node Proxmox cluster, ideally with 12 OSDs, you would need 4 disks per node. But honestly, for this Proxmox setup, I just wanted to keep it a little simple and honestly not too expensive, yeah? So I have decided to just use a 2 terabyte NVMe for each node, and that becomes exactly 1 OSD. So it technically works as well. The 2 terabyte NVMe, by the way, is just my personal choice. Technically, you could also think about building Ceph with SSDs, and you also don't need exactly 2 terabytes, of course. But in my opinion, NVMEs are just the best option here because they give you high IOPS and lower latency, and also because we need all the virtual machine disks on all of the drives, you need enough space to store them all, so therefore 2 terabytes. Also keep in mind, if the disks can push a lot of data, your network and CPU also have to keep up as well. And that is the third recommendation, networking. I strongly would recommend you to use 10 gigabit networking at minimum, which is in line with Proxmox's own recommendations. And ideally, that traffic should also be separated from the normal cluster communication. So you have one for the public Ceph interface, one for the Ceph backend, and also theoretically a third separate network just for Proxmox HA. Again, this is where I just had to make some compromises. You might ask, can you make it work with 1 gigabit for a lab? Yes, probably. But if you actually want to run many virtual machines or you want to often migrate VMs, I personally would not want to run into problems because of low network speed. And regarding that separate network interface for Ceph, like I said, I'm not following that recommendation. I'm just using the same network interface because I just didn't have any other. But if you want to do it right, use a dedicated network interface just for Ceph. So that's it about the requirements. I know, guys, there's a lot of theory in this video, and we're not done yet. Also, these are all high requirements, and that might scare off some people because I know buying servers, buying 10 gigabit network interfaces and separate NVMe drives, that is an expensive project. But as you have seen in some areas, you probably can make a few compromises. For example, when it comes to the number of OSDs and whether you want to use a dedicated network interface for the backend traffic. But that is a decision that I personally made for this project. I wouldn't want to cut any more corners here, because there's a reason why Ceph has these high requirements. Like I said, you have to keep in mind every operation on each of your VM disks has to be distributed across all the nodes constantly. So the more disks you have, the more VMs you run, the faster your network interfaces, CPUs, and memory has to be. But honestly, guys, I don't have any other experience than the project that I just did. Maybe some of you might want to share your experience in the comments as well. That could help others to get this up and running. But I think we've discussed that enough. Let's now move on to creating the actual monitors and managers of the Ceph cluster, because that's also an important step that you should not forget. Now, the monitors keep track of the cluster's state in quorum. So in a 3-node cluster like this, I, of course, want 3 monitors in total. 1 on each node makes, of course, the most sense. And the idea is pretty similar to what we already talked about with the Proxmox quorum. So usually, you always want a majority of nodes to agree on what the cluster should look like. So if one node goes down, the other remaining 2 monitors can still agree on the state of the Ceph cluster. Basically, the same reason why we used a QDevice in the 2-node setup. Then I also created 3 managers, 1 on each node, and this concept is a little different, even though manager sounds quite important, and yeah, it certainly is, but the manager is not the thing that gives the cluster quorum. This is more like a service layer on top that provides additional status, metrics, and management features. So in a 3-node Ceph cluster, you should add at least 2 managers, because Ceph actually just uses 1 manager as the active one, and the others stay available as standby. So if the active manager disappears for whatever reason, another one can take over. In my case, I just wanted to keep it simple again. It just plays managers on all of the nodes, just the same way I run the monitors, but technically you just need 2. Alright, so now let's come to creating the actual storage, creating OSDs and RBDs. And yes, I know this is another place where the terminology can get confusing. That's just how it is in Ceph, yeah? Again, an OSD stands for Object Storage Daemon, and like I said, I wanted 1 OSD for each NVMe drive, so 3 in total, 1 on each node. The cool thing is you can also encrypt the OSD if you want, and then select a device class. So, by the way, selecting the device class does not magically make the device faster, of course, yeah? This is really just used as a label that Ceph can use to decide where to place data. So if you're mixing different storage types, that might be a useful setting, but it is not really required. By the way, make sure that you're selecting the correct empty disk, because creating an OSD will completely wipe the selected drive. So make sure that you don't have any data on this that you care about. Now that we have the storage workers in place, the next step is to creating the actual Proxmox storage that we can use for creating or storing VM disk. So now I finally created 1 RBD storage. By the way, RBD stands for RADOS block device. And in simple terms, this is the Ceph block storage layer Proxmox uses for VM disk. So the actual VM disk becomes an RBD image, and that image is stored inside a Ceph pool. That's why you have to select it under Proxmox Ceph pools. So to explain it in other words, these are where the data lives, and RBD is the virtual disk layer that Proxmox gives to the VM. For a Ceph pool, you can select a size, which is 3 by default. So that means Ceph is trying to keep 3 copies of every object, including the primary copy. So with 3 Proxmox nodes and 1 OSD per node, the goal is basically 1 copy on each node. Then we have minimum size. This means that Ceph will still allow I/O as long as there are 2 copies available. So if one of the OSDs goes down, the pool can still continue running in a degraded state, but still write and read data. So I certainly would not change this setting here, because if you set this to 1, then Ceph could keep accepting writes with only 1 remaining copy, and that is where you can run into some data loss scenarios. scenarios. Then the next setting is the crush rule, which is replicated, and we just leave this by default. And then comes another slightly confusing concept, the number of PGs. And PG means placement groups. So these are groups that Ceph uses to place data on OSDs. Because Ceph does not manage every tiny piece of data completely on its own. It puts this data into placement groups first and then distributes these across the different OSDs in a cluster. So in a large Ceph cluster, more PGs can help because Ceph has then more groups that can be spread across many different disks, which helps with data throughput and so on. But in my setup, because I only have 3 OSDs in total, 1 on each node, and I use a pool size of 3, so every PG basically needs all 3 OSDs anyway. So more PGs don't actually help me. They mostly just add additional overhead because Ceph has to track, manage, and recover every PG later. Proxmox give you a general default value here, but in my tiny home lab setup with only 3 OSDs, I'd reduce that to 32 to keep the overhead lower. But again, don't worry if you're unsure about this setting. It is not catastrophic if you leave that by default, okay? So then we also have 2 other settings, the target size. So this is useful when you know the absolute size of this pool that it should grow to. So for example, this pool should only use 500 gigabytes or 1 terabyte. Or what is even simpler, if you just set the target ratio, this is more like a relative weight. So if you only have 1 RBD and you basically want to use all the storage, you set this to 1. And that basically tells Ceph, hey, the pool is expected to use all the available Ceph capacity. So once that is done, you can see that the new storage items appeared immediately on all 3 nodes called RBDs, so the name that I just defined. And now I could use this just like any normal Proxmox storage. I could now store VM disks and container volumes on it, just like with any local LVM. And I immediately tested this by basically just moving one of the test server VM disks from the local LVM to that new RBD Ceph storage. And that actually took quite a long time once it was copied, but then I could just remove the old unused disks from the VM and start it up normally. And what I've also done, I've done a quick test by running a ping on this virtual machine and did a live migration, so moving this VM from the first to the second node. And yes, you can still see that it transfers some data, but this is not the actual virtual machine disk. The disk, again, already lives on Ceph. You can see this when you click on all the RBDs, that it contains the exact same data. What Proxmox mainly has to copy now is the memory state of that running VM. So that means that the virtual machine can keep running while the migration happens. All the services stay online, the ping keeps going, and the virtual machine can also read and write data to its disks. And at the final switchover, there might be a very short hiccup because Proxmox has to stop the VM on one node and resume it on the other node. But after that, it should immediately respond again. And just to be clear, this is live migration during planned maintenance. If one node suddenly dies, that is slightly different because then you cannot copy the memory, but for updates, reboots, and moving workloads around the cluster, this is exactly the experience I wanted. So yeah, that's it about my Ceph Proxmox cluster setup. And I know, you might be wondering, was it actually worth it? Because yeah, I know Ceph has high requirements. I needed to buy 3 2 terabyte NVMEs. I needed to buy a complete new Proxmox node. And it has a lot of terminologies, new things to learn, and a lot of moving parts just to do live migration. So yeah, if I'm honest with you guys, I would not recommend this setup for everyone. If you're just running a few VMs and you're happy with your setup, then you don't necessarily have to care about live migration. Or if your network is still on 1 gigabit, this is probably not the best setup. But for my setup, I think still, it makes a lot of sense, mainly because of plant maintenance, because I run many services in my home lab that I really don't want to shut down every time I do an update or reboot a Proxmox node, like my DNS server or important databases. I just want to keep them running in a consistent state. And this is where this 3-node Proxmox cluster and the Ceph storage makes a lot of sense, because I can easily move these virtual machines to another node, reboot the server, and keep everything up and running. And the second second reason is faster recovery, because if one of the Ceph disks has a problem, or if one Proxmox node completely dies, the virtual machine disks are not sitting on that machine anymore, and I would need to copy all the data from the backup. Ceph keeps replicas across the entire cluster, so the two other remaining nodes still have access to the data. So I can easily start all the virtual machines up on the other nodes, and everything is still up and running. One important thing I still want to say, that Ceph is not a backup. The same like redundancy is not a backup. So I still use a Proxmox backup server. And yes, you still should have proper backups. By the way, you probably might have noticed that the third Proxmox node looks a bit different than the others. And yes, the reason for this is that this actually is my backup storage, or it basically became my virtual NAS system. So this is not the end of the story. I still want to show you that setup in a future video, maybe when I do my new home lab tour somewhere in the middle of this year. And also, I have another project that I'm planning that relies on the Ceph storage. You cannot just use the Ceph distributed storage system for your virtual machines. You could also connect other services and maybe containers that are running on your VMs directly to this Ceph storage. At least that's what I've heard. And of course, Ceph was one of these critical puzzle pieces that I just had to solve first. So if you want to see more about that and any other future home lab projects, then make sure that you subscribe. And if you're already doing this, you can also give this one a thumbs up. I hope this video helps you, and maybe it was an inspiration for the one or another home lab project that you might do in the future. If you want, you can leave me a comment, or let's continue the discussion on my Discord. That would be really amazing. But at this point, I think we're done for today. Thank you so much for watching the video. I hope it helped. A big thanks goes out to all of my supporters and YouTube members. You guys are really amazing. And of course, I'm gonna catch you in the next video. Take care. Bye bye.